function. Now this is just the linear function, right? And then we do we just sum them together like this, and then we do this nonlinear element where we throw them through like the sigmoid function, right? And so then it activates this way. Okay. So what I'm going to do is I'm going to go through this real quick, and I'm going to show you how a neural network would actually work, okay? And hopefully there won't be any questions. All right, so anyway, so the idea behind neural networks is what we're going to do is we're going to do this thing going forward, right? And then we're going to find out at the end of the neural network how bad we did. That's going to be our error. And then we're going to feed that back through and adjust everything. Be like, okay, we've gotten closer, and hopefully the next time we come through, it'll be better, right? And so we can do this for all of our examples. All right, so let me feed in that. Let me feed one guy through. So we're going to have, this is going to get crazy. We're going to have, x1. And so what we're going to do is we're going to activate this neuron. And then we're going to activate the next neuron. And the next, all right? So there goes we've done our first layer. And then we're going to take the output of the first layer and feed it to the second layer. Right? That one and that one. And so like, if you're paying attention to that previous slide, this is still, we're just doing the functions through all of this stuff. But you can see these weights. I should probably talk about this real quick. These weights, there's a different weight on this arrow versus this arrow. This weight's called like weight 1 to 5 because it goes from 1 to 5. Usually that's how this notation is written. And this is like weight from 2 to 5 and things like that. All right, so we're going to keep doing this a little bit more. And so we're going to activate our final layer. And then we're going to have some kind of output. All right, so the output was Y. And since this is like supervised learning, we know what we should have gotten. Or we have some idea of what it should have been. And we're going to say, it should have been Z, jerk. Right? So we have some kind of error. And we're going to feed this back through the network. And here we go. All the way. All right? And so then what we're going to do is we have all of these errors in all of our nodes, and we're going to update the weights. Okay, so we can see like W prime of x1, that's this weight right here, is going to be equal to the old weight, W, plus some, some update mechanic of like our weights. Okay? And that's kind of like another show. But anyway, we go through and we do this for everything. And now I have to go through really fast. All right, so anyway, that's neural networks. Perfect, right? No problem. All right, so anyway, we're going to talk about neural network problems because that's what I want to talk about. It was popular in the 90s and 2000s. If you went to school in the 90s, you got to learn all about neural networks. Try to program a few, make them blow up, et cetera, et cetera. Like I said, there's a lot of problems. Like, well, it's not like a problem. It's just like we're not smart enough to understand what actually neural networks are doing. The number of hidden layers, the number of nodes in the hidden layers is like a black art, right? So this is like train it, see if you get good results. If you don't, well, maybe the neural network's not the right shape or size.